Hello, welcome to my newest YouTube. I'm going to talk about a subject that is really simple that shows why we have trouble learning math. Nobody ever taught you the best way to do some long subtraction. Well, let's see if I can do it. This is how you were taught to do long subtraction. You basically modified the minuend to take into account numbers that were smaller in the minuend than were in the subtrahend. You did that by borrowing powers of 10 from the digit to the left of that number. So here we've shown how we've corrected the numbers at the top. And we now begin. We subtract 8 from 15, and we get 7. We then had borrowed a 1 from the 4, and the 10's next place, and that makes that a 9. And then and the 4 becomes a 3. Okay, and you can see the 300 plus the 90 plus the 15 now gives back 405. And again, we borrow 1 from the 7 to make the 6 a 16. Okay, so now we subtract. 8 from 15 is 7. 0 from 9 is 9. 2 from 3 is 1. 8 from 16 is 8. And we're left over with the 6. Now, here's the easy way to do it. I just write the answer down. I did it in my head. Well, I assume you'd like to know a little bit more about what I did. Okay, so what I basically did is that instead of working and focusing on the minuend, I focus on the subtrahend. Take into account that if I add 10 to the subtrahend, it's like subtracting 10 from the minuend. So I start over here, 8 from 5 or 15 is 7. Since I had to borrow from the previous distance, I just add 1 to the 0, and I take 1 away from the 0, and I get 9. Okay, since I had to borrow for the 0, I borrow from the 4, but instead of doing that, I just add 1 to the 2, which gives me 3. And 4 take away 3 is 1. I had no carry digits, so I don't add anything to the 8. 8 from 16 is 8, and I then add the 1 into this 0 next to it, subtracted from 7. So let's go and look at this directly. 8 from 15 is 7. 1 from 10 is 9. Add a 1 to the 2. 3 from 4 is 1. No carry, so 8 from 16 is 8. And 1 from 7 is 6. This was a bit difficult to describe, but a lot easier to do. The reason this works is, as I said before, minus 10 plus 10 is equal to 0, which is the definition of negative numbers. Adding 1 to the next number in the subtrahend to the left is the same as subtracting or borrowing 10 from the minuend. I still fall back on using the way I was taught because it's hard to break old habits. Let's look at this again. Okay, so we can see it one step at a time. 8 from the 15. 7. Now I move over to the 0. I add a 1 in there because I had to borrow. So 1 from 10 is 9. I had to borrow again. So I add 1 to the 2 is 3. 3 from 4 is 1. No borrowing. So I can just subtract the 8 from the 16 directly. And since I did have to borrow from the 7, adding 1 in here and subtracting from the 7 gives me the 6. Practice it a while. It's really easy and less chance of making mistakes. It took a knowledge of negative numbers and number structure to develop a better algorithm. If you used the traditional subtraction algorithm in division, it would be a mess. This suggests that the mathematician who developed the subtraction algorithm to understand number structure, negative numbers, the concept of zero, and subtraction. Then, like lemmings, the rest of the mathematicians and us followed the procedure without challenging or questioning and asking questions. And this is what we're always told in mathematics, but we don't do it. You will notice that I tried two approaches to explain my algorithm because teaching requires that you make it easy for the student to learn. The first approach, even I had trouble understanding it. Those teachers who do not teach the curriculum will be more effective in teaching than teaching their students, but they will have to take a lot of criticism from administration. To be more successful in teaching mathematics, we have to understand our own limitations and let the students know that it is understandable that they will not fully understand, but over time, by asking questions, they will. Do you want to understand why you feel uncomfortable with math? Look at my latest YouTubes. New Foundations basically looks at everything in mathematics and shows it by looking at it a different way. We can now remove a lot of the anomalies that we see already. New Frontiers basically looks at the fourth dimension. I'm not sure that I fully understand it, but I was able to understand complex numbers and complex roots a lot better after I played around with this approach. I am interested in improving math education. Contact me if you want to help. And there's my um, email address. Thank you again, and hope we can all help make math better for the world.